mentioned that very first week in teaching object-oriented programming, there are two approaches. There are professors who take an early objects approach where they introduce object-oriented programming and creating custom classes from the outset. And then there are those who are late objects professors who teach more of a traditional programming approach and then get to creating our own custom classes. And I mentioned that I am a late objects professor. We've been programming using classes, but now we're going to get into creating our own custom classes. A class is simply a blueprint of an object. And we mentioned very early on that classes and objects can have properties, methods, and events. And an object is simply an instance of the class. Taking that blueprint idea, the blueprint is the paperwork of what a house would look like and how it would be constructed. But until we actually build the house, it's just a blueprint. But building the house, we now have an instance of that house from the blueprint. We've been using classes all along with instances of classes and their properties, methods, and events. When we create a button such as this btn generate, we're creating an instance of the button class. Same with our label lbl_num, and we're creating an instance of the label class. And those exist inside our form, which is also a class. And each of those three instances, the form, the button, and the label, have properties that we've changed, such as back color and the text. They've had methods that we've called, such as the clear method to clear the text of a label. And they've had events. We've done the click event of the button. And we see that in our code. You've probably noticed that everything we code is inside the class definition of Form 1. But inside that code, we also have some classes that are referenced, such as an object, event args, or an integer. And we've created instances of objects. So sender is an instance of the object class. btn generate is what we named our button, so that's an instance of the button class. RND is an instance of a random number generator. ABC is an instance of an integer variable. And LBL is what we named our label. That's an instance. And we have events. We're handling the click event in this case for the button. Properties. We're setting the text property of lbl_num in the small little piece of code. And then we have methods. And I mentioned you can always tell methods by parentheses. On the line of dim ABC is integer equals RND, we're calling the next method of the random number generator and passing in an argument of 100. And by adding 1 to that number that's generated, we're getting a value between 1 and 100. Same thing, we take ABC as an integer, we're going to convert that to a string to put it into the text property of lbl_num, and that toString is a method. It does something. It converts the integer to a string value. Now we see that dim RND is new random. Random has parentheses, and that's a very special method called a constructor. That is the method that constructs the class instance from the class blueprint. Just as that house analogy, we're constructing a house from the blueprint. And we'll look at how to create constructors when we create our classes. That allows us to create multiple objects from the same class. Let's develop a project in which we'll create a custom class. Most classes are going to be data classes. Data class contains properties and methods focused on working with the real-world object represented by that data. In this project, we're going to create an employee class, which we want to have the first name, the last name, and the hourly pay rate of the employee. And we'll use that to calculate their gross pay for the week based on the number of hours they've worked. And we'll also have some methods to update their pay rate either by a percentage or by a particular amount of hourly rate. I tend to create my data in Excel with each column representing a field of the data and each row a record. And so on the left is the Excel data. And then I want to save that out as a text file. In this case, I'm going to save it as a comma separated value file or a CSV file. We'll take that CSV data file, we'll place it in the subfolder of bin debug net8 windows along with the executable that we'll generate. That way our data is with the executable and it's easy to find it and read it in. We also want to make that file persistent. So if we give a raise to an employee, then we want the data saved back out to that same data file reflecting their new pay rate. I've created the interface of my project with a list box named LST employees. It's going to list all of our employees that are going to come from that data file through our employee class. We'll be able to click on each name in here and see the employee's name in our label called LBL employee and their tax rate in LBL pay rate. We'll be able to enter a number of hours that they worked in a text box named TXT hours. Click the button of BTN calculate and see their gross pay in the text box TXT gross pay, and I made that one read only. Then I have a button of BTN raise percent and another one of BTN raise amount that will allow us to provide raises to the employees of either a percentage or a hourly amount. Button up here, BTN read will read in the data, and BTN write will write out the data. Now oftentimes I will read the data in automatically when I open the form, and I will write the data back out automatically whenever I make changes to any of that internal data. My next step is to create the data class. I'm going to go to my Solution Explorer, right click on the solution and choose Add Class. And so I'm adding a class under common items. By default, class1.vb. I'm going to rename that to employee.vb. And I now have an employee.vb class in my Solution Explorer, and I also have the empty class in the editor. I need to add code to the empty class. Let me pause the video here, write my code, and come back and show it to you. Welcome back. Here's my employee class code. I have 3 class level variables of LName and FName as string and pay as double. My constructors, I'm passing it 2 strings, LN and FN, and a double value of PR, and placing those values into LName, FName, and pay. That's going to create the instance of my employee. We'll access those values with public properties, and my property names are last name, first name, and pay rate. And they each have getters and setters. So on the setters, we're taking the value that's passed and setting it to the value for LName, FName, and pay. And then for the getter, we're returning the value of LName, FName, and pay. I also created a read-only property called full name. And it's only has a getter since it's read-only, and we're going to return the interpolated string of FName space LName. And then some class methods. One is to calculate the gross pay, and we're going to pass it the number of hours that's provided in the text box in our form as a double value. We're going to calculate if there's overtime by if there's more than 40 hours. Those hours will be considered overtime above 40. Our regular hours then will be, if they're greater than 40, will be 40. Otherwise, it'll be hours. I'm going to dim my pay as double and take that as hours times pay rate plus the OT, our overtime hours, times pay rate times 1.5. So pay time and a half for the overtime. I'm going to return my pay. That will be our gross pay. 2 methods to give raises. One, we're going to pass it a percentage as double, and we're going to divide that by 100. We'll calculate the double as pay rate plus the percentage times pay rate. So we're incrementing it. We're going to convert that to a string to 2 decimals. So we're going to drop anything beyond that second decimal. That's making it a string. Now I want to convert it back to a double value, and that'll be our new pay rate. For the amount, pay rate is just going to be incremented by the amount. And then finally, I want to be able to write this data back out. So I have a function called writeRecordCSV, comma separated value. As a string, we're going to return the interpolation of LName, comma FName, comma pay. That's our employee data class. Let's go to the code for the form. We have 5 buttons we need to code, as well as the list box when the user makes a selection. So when they select a name from the list box, it shows the employee name and the hourly pay rate. Let's go to the Load Data button. I have 3 class level variables. The first one is a string variable called data file, which is the name of our CSV file. And then employees is a list collection of type employee. That's what we're going to use to populate the list box as well as pull up the information for the selected employee. For that selected employee, I want to have an integer variable called empIDX, and that'll be the index of the selected employee. I'm going to have a Boolean variable named unsaved data, setting it equal to false. Since we're not automatically saving our data, we want to keep track of if there's data to be saved. So when the user goes to close the application, we can warn them that there's data that needs to be saved. It's too easy otherwise to make changes to the data and forget to save it. That's why I always like to autosave. But this is sort of a compromise. So our btn read.click event handler is calling a subprocedure called read data, and the btn write.click event handler is calling a subprocedure called write data. Now, if we want to automate this when we first open the application, this could all go into a form load, and we wouldn't have to bother to click the button to read the data. But I wanted to show you different options here. So for the read data, I do all this in a try-catch because a lot of times problems can happen with reading data. The data could be in the wrong format. It could be corrupted. The file could be missing. The file could be opened by another application. So I just want to do this in a try-catch. We're going to dim SR as stream reader. We're going to open SR as our data file with open text. We're going to read the first line. That first line is the header file, and it says last name, comma, first name, comma, pay rate. It just tells me what the different fields are. We're not going to do anything with that, so we're going to read that first line and ignore it. Each record has 3 items in it, last name, comma, first name, comma, pay rate. And so we're going to create an array called fields of type string that contains 3 elements. So that upper indexes 2. A string variable called nextRec, and then I'm going to clear the employees list. Do while, not sr.end of stream. This is going to be a loop that's going to read each line one at a time, and we'll keep reading as long as there's data to be read. The alternative is we could say a do while sr.peak does not equal -1. Both work just fine. NextRec is going to equal sr.readline. So we're going to read the next line, and if that next line, nextRec, contains a comma, then we'll do something. If it doesn't contain a comma, the data is invalid. And what we'll do is fields equals nextRec.split on the comma. That'll put those 3 items into each of the elements of fields. And then employees, our list, .add. And what we're going to add is a new employee, and we're going to call that constructor, passing it fields element 0, fields element 1, and fields element 2 converted to a double. Now I have an else fork that I didn't use. We just make that an end if, and then the end of our loop. So that will read all the data. We want to make sure we close our file, so sr.close. That data is now all in our employees list. We want to iterate through that list and populate the list box. So for each emp as employee in employees, that's our list, lst employees, our list box, .items.add, we're going to add emp.fullname. Now, it's probably a good idea that I didn't put in here is let's also clear our list box. So lst employees .items.clear. So we're going to clear our list box first, and then we'll add the items in. That's going to happen in a loop. Message box, we're going to use an interpolated string of the employees.count, and it's going to tell us the number of employee records read in. If something goes wrong, and again, there's lots of things that can go wrong, then we're going to take the exception and pull up the message and display that with the title of something went wrong in a message box. Here's our write data. So again, we're going to do this in a try-catch. We're going to dim SW as stream writer, SW equals file.create text, and we're going to create the text of data file. Now, you might be tempted here, there's a file.append text. We want to use create text. We want to overwrite the data that's there. If we use append text, we're going to add to it. And now every employee is going to be in there twice. SW.WriteLine, we're going to write the header line back out of last name, comma, first name, comma, pay rate. And then for each emp as employee in employees, our list, we're going to call SW.WriteLine, and what we're going to write is that emp.write write record CSV method. That loop will write every record that's in the employees list to our data file, and then we want to close it, sw.close. And at that point, I'm setting unsaved data to false. We just saved our data, so there's nothing unsaved. Again, if something goes wrong, we'll show the exception.message and say something went wrong. And I see I misspelled something. And I did that up here because I actually copied and pasted that line. Here's our list box. If the user clicks an item in the list box, we're going to make sure that empidx equals lstemployees.selectedIndex. When I get that selected index number, we want to make sure something's selected. So if it's greater than or equal to 0, something is selected. If it's a -1, nothing is selected. If something's selected, we're going to show the full name of the selected employee, employees element empidx in the LBL employee.text. And in the LBL payrate.text, we'll show the pay rate. And we're going to convert that to a string with 2 decimals and a $sign, so the C2. Otherwise, we'll put employee name and $0.00 in the pay rate. That'd be if it's a -1. Our BTN calculate button will take employees element empidx dot, and we're going to call the calc gross pay method, and we're going to pass it the value that's in txt_hours.text. We're going to convert that returned double value to a string of currency. That goes into txt_gross_paid.text. The raise percent allows us to raise the selected employees by a percentage, and we're going to have them enter that percentage in an input box as a percent. So they might say 4.5%. We're going to replace then that percent with nothing, and we're going to trim it. So make sure we get rid of the percent sign so we can convert it back to a double. So we're converting that to CDBL. And then we're going to call employees empidx.giveRaisePercent and pass it that double value, PCTDBL. We want to update the values if that's the case. So we're going to update the LBL pay rate and the LBL gross pay with those new values. And we're going to set unsaved data to true so that if we try to exit the application, it's going to warn us that there's unsaved data and gives us a chance to save it. Now, the reason I like to automatically save data rather than doing it this way is this works great if you just try to close the application. But if there's a power outage or something and your computer shuts down, that unsaved data is lost. We'll do a messagebox.show. We're going to show the percentage increase, the old pay, and the new pay. Do the same thing with the raise amount, but here rather than percentage, we're raising it by a certain dollar amount, such as $1.25, and we're simply incrementing the pay rate by that amount, and then updating those values again and setting unsaved data to true. Maybe times we want to give an employee a raise by percent, maybe it's a cost of living percent, or you want to give them a raise by a certain dollar amount. So we give 2 options there. Now, when that unsaved data is true, we want to give them the option to save the data if they try to exit the application. In the form, I went to the form closing event and specified check for unsaved data as the name of the method. And so it created this method for me. And this will happen anytime we go to close the application, whether we had a button to do it, or they're clicking the X box, or they're choosing Alt-X if we had a menu system. It will handle all of those. So if unsaved data, if that is true, then we're going to show a message box that says you want to save your unsaved data with a title of save and message box buttons of yes, no, and an icon of question. If they say yes, we're going to call that write data method. Let's give this a try. Here's my application running. I'm going to load the data. This goes out to the employees.csv file and reads that in. There's my 8 records that were read in. I can choose one, such as Ellis Emerson. Ellis Emerson makes $17.50 an hour. Enter the number of hours. So if we said 20 hours, calculate pay, that's $350 gross pay. Let's give Ellis a raise. If I raise the amount, I'm going to do something just so math is easy. Let's raise the amount by $250. And I'm going to put a $sign in front of this so we can see that it actually strips out the $sign. So that should take us to $20 an hour. And it does. So the $250 increase, the old pay was $17.50, the new pay is $20. And the new gross pay of 20 times 20 is $400. Now let's give another raise here. And let's just say 5%. So now that 5% of $20 is $1. So 5% increase went from old pay of $20 to new pay of $21. And we see the new hourly rate reference there, the new gross pay of $420. And I can go to another employee and see their information and calculate their pay. One thing you might want to do here when we go to a new person is to clear out that gross pay so it's nothing there, it's 0.00. And this is why we test, to find things like that that will make the application better. But let's just say we go to exit. I haven't saved anything, and I get this dialog box that says save your unsaved data. And I'm going to say yes. Now I'm going to run it again. Load my data. Get 8 records ready, and let's go back to Ellis Emerson, and our $21 of the hourly rate has persisted. So that one little change I suggested, we can go back to where we're gross pay dot text equals $0.00. And now every time we choose a new employee in that list, it'll clear out the gross pay. And we have to click the calculate button to calculate it. Let's test that. Load data. Choose Blake Brown. Calculate pay. And now if I go to Frankie Fredericks, it zeroes out the gross pay. If you just jumped into this video, you can see all the videos from the Programming Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.